the house has been tested, and it's there, but not a concern. Now it really is a concern. So as we continue on, this has been something. A couple weeks ago, we had a public information session, sort of to recap. And the biggest comment we got from that session was, hey, we need an answer from water as to what's going to happen to the community and the houses that have been. And I think from Ty and Ron, the engineer's perspective, we've been working very hard with wastewater, but there's a lot of different folks and entities at DEC. And it took a lot of communication and meetings we were involved with. So yesterday at 4 o'clock, 3:30, we had a meeting, which is that absolutely they understand the impact of this issue on the drinking water and drought. And that we had another meeting at 8 o'clock this morning, and the general consensus is we have done a really complete job getting us on wastewater to 60%. But at this point, and we're going to present that data. Remember, 8 o'clock this morning, so water's got to catch up. And so I just wanted to be very clear where we just found this out. We finally got an answer on the water, and we're going to give, I think, really complete information at the 60% level on our wastewater alternative. But then the general recommendation from DEC is to get that caught up. So that's our background information. So I'm Erin Moore from Ty and Bond. I'm the project manager. I'm going to very shortly turn it over to Kyle Courtwright, who is one of our engineers, and is going to give the 60% wastewater presentation. We're going to identify this water impact. And then Chris from Wyndham Regional is going to facilitate a question and answer session. We've got the folks from the town here, obviously. We have on remote DEC. That's why we've been messing around with the speaker, because it's very important to hear what they have to do. And then just do your best to understand. We have just gotten the new information as of this morning, where DEC feels that the water system analysis needs to be. So we're sharing that with you practically real time. Again, if you joined us a couple weeks ago, you know that was probably the most significant comment that was made from the community and their questioning. So, and with that, I'm going to turn this over to Kyle, and we'll talk through wastewater, and then be able to facilitate questions.
Thanks, Erin. I'm going to stand close to the speaker, so hopefully everybody can hear me. That's on Zoom. So yeah, as Erin said, I'm Kyle Courtwright, Ty and Bond. I don't think this is my first time doing the presentation here. Erin's doing the face. Can't hear me? Okay, I'm gonna try to speak up more. What's that? Yeah. I'm afraid if we turn those off, it's going to be brutally hot. Fans at the back, okay?
Can y'all make it without fans for this? All right, you're tough for monitors. You can do it.
Okay. So just to give a little presentation outline of what we're going to be talking about today. Aaron touched on a lot of these already, but we're going to give a little background, try to get everybody up to speed again, because it's been a while since we've been here. Talk about what we did at the 30% meeting. That was about a year ago. Talk about that drinking water, and then go through in detail some of the 60% reports, what we're calling this, and go through some of those details, mainly related to the wastewater system. And then we'll talk about some next steps, and then open it up to questions. So how did we get here? Just a little timeline here. Back in 2020, the village sent out a survey to try to solicit some feedback from community members about water and wastewater systems. The village ended up submitting an application for ARPA funding in 2021, and ARPA stands for American Rescue Plan Act. Then in 2022, they hired us to complete this feasibility study. That was through the DEC Engineering Planning Advanced Program, essentially a grant to to do this feasibility study. And then in May 2022, we kicked off the meeting. September 2022, we had that 30% meeting. And then shortly after that, in October, the town was appropriated about $4 million for village wastewater project through ARPA, through that application that they submitted. Then there's been a bit of hiatus I'll talk about here in a minute. So the last winter and into this spring and summer, we've been working on doing some site investigations, trying to find at least a feasible site and developing the 60% report, which is where we're at now. So it's a collaborative effort between everybody here, the town, the community, DEC, Wyndham Regional, and all this work so far has been grant funded. So just touching on the goals, the main goal here from our perspective is to try to identify some technically feasible alternatives for drinking water, wastewater, and then ultimately there's going to be a report. So this is the 60% phase, so we're about halfway through it. That will discuss all these alternatives, provide some details, come up with a cost estimate and what it might cost the users of that system if it were to go forward. And so how we try to get there is, number one, understanding the issues, getting people's input on what they think is a priority. And then the process, I mentioned this, it's a 4-step process, call it 30, 60, 90%, and then final design. So we're in the 60% phase today. So why would Grafton want to go ahead and do one of these feasibility studies and look into potential water wastewater system? A few reasons. Number one, the village center is developed. We're right here in the village. There's relatively small parcels that are pretty close together. And what happens there is you got drinking water wells relatively close to leach fields. And that can become problematic, especially if they're not maintained, or old systems that have failed. And there's also some concerns that Aaron just mentioned with PFAS around the school as well. We've also seen with other communities that without a public drinking water wastewater system, sometimes that limits opportunities for certain types of housing, businesses expanding. For example, if you want to add a bedroom on top of a storefront, something like that. Sometimes you can be limited by the size of your parcel and septic system. It's also difficult to establish water-intensive businesses like restaurants and breweries. Sometimes that can be limiting. The lack of a public sewer system can be limiting there as well. So then why now? One of the big things is fundability. So right now we're kind of in a unique point where there's some historic amounts of funding out there, probably more than's been since the 70s, during the Clean Water Act. And as an example, that Grafton was appropriated about $4 million already for a village wastewater system through the ARPA. And like I said, there's some current concerns with water quality, mainly surrounding PFAS. And just want to make the point too that Grafton's not the only village or town considering this. All those red dots on that map there are other small communities who have no water or sewer system. So going back about a year, it's like the end of September last year, we had the 30% meeting. During that meeting, we talked about a service area. So service area is which parcels would be included in the system and be served by a public system. We came up with a flow estimate for that service area. And then we spent a lot of time talking about two sites mostly for a wastewater system. If you recall, for those of you who were there, one was the Village Park site, and the other was the Alpine Field site, which is the field back behind the cheese factory up in the hill. We got a lot of good feedback from that 30% meeting, and kind of the general takeaway there was that Alpine Field was generally preferred due to its size and kind of isolation from the village. So it looked pretty promising on paper. I'll talk about some site tests we did there in a minute. And then kind of that last part we talked about during the 30% meeting a year ago was considering a drinking water system. So speaking of drinking water systems, as Aaron said, we've been working closely with the DEC over the last essentially year. And the drinking water system is a little bit complicated situation. So in our original scope, we had to investigate a community drinking water system. That was in our scope because it was a kind of a hot topic in the town at that time and a concern because of the PFAS. So Aaron touched on this a little bit, but just for those of you who don't know, PFAS is essentially a man-made chemical that has been used in all sorts of consumer products for many, many years, I think back to the 40s. And it's been found in a few wells around the school. And one thing to note is that PFAS persists in the environment for a long time. It's important to remember here in a second when I talk about how it relates to a wastewater system. So some specific considerations for Grafton related to a drinking water system. We could consider just a standalone public drinking water supply system and no wastewater system. So that's an option that we wanted to look into. And then we started looking into the Village Park site and what it would take if it was feasible to use that site for a wastewater system. And there's what's called a 2-year time of travel requirement, which just means you want your wastewater system to have no wells downstream within a 2-year time of travel. So that wastewater that goes back into the soil needs to take about 2 years before it gets to a well. And then given the location of the Village Park site relative to the village, it's pretty much uphill the entire village. That would require us to either relocate all those wells in the village downstream of the Village Park site or provide a public drinking water system for that area. So my point being here is that the Village Park site could only be considered for a wastewater system if there was also some form of public drinking water supply system for the village. And then PFAS, drinking water, and wastewater are all related. My point being there is if we were to take the water, say, from some of these wells that had PFAS in it, sent it out to the wastewater system, it would ultimately end up going into the groundwater wherever that wastewater system site is, unless it had some specific treatment system for removal of PFAS, which is another challenge. But, so like I said, that kind of complicates things. They're all related. All three of them kind of come together. So one of the things that became clear in discussions with the DEC when talking about a drinking water supply system is that the town, in order to permit a new community drinking water system, the town would need to demonstrate what's called technical, managerial, and financial capacity. We use TMF for short. Essentially what that means in short is that the town needs to have enough personnel, proper finance to successfully operate and maintain the drinking water system. So that would be a challenge for Grafton, and Grafton's not alone in that. Any small village or community struggles with that as compared to like a city, for example, where they've got a lot more resources. So that's one major challenge that we've run into here with the drinking water system. So path forward. The DEC has determined that a separate drinking water system preliminary engineering report would be the right next step to consider a public drinking water system, which would also need to be considered if we wanted to consider the Village Park site. So, and that drinking water PER would be fundable through ARPA, through a grant through ARPA to do that. It's essentially the PER is what we're doing now, but the one we're doing now has been a little bit more specific to wastewater. So we'd essentially redo this project with a specific look at multiple options for drinking water. So I know it's a little hard to follow. It's a little bit confusing. This is just a very simple diagram, kind of process flow diagram of how we would move forward to consider a drinking water system and even a wastewater system, truthfully, because, like I said, there would need to be some sort of drinking water system to address PFAS before we could send it to a wastewater system. So right now, we're in the wastewater feasibility in the orange, 60% report. Moving forward, what we would do is take a little pause on the wastewater and then pick up the drinking water and get that to a 60% level, and then kind of bring it all together and move both wastewater and drinking water forward in a collaborative effort. So, that's a lot. There's probably a lot of questions on that. I think what we'll do now is I just want to focus on the wastewater system for the rest of the report, the feasible alternative that we have in there right now, specific to wastewater, and then we can get back to some questions on the drinking water. So like I said, first step for wastewater is to determine a service area. So we did that. It was focused around the village center and what's called the village center planning buffer, which is about a quarter-mile radius around the village. So just some quick stats. In that service area, the area highlighted in black, there's 84 parcels total, about 56 residential, 23 commercial, 5 vacant. And then we came up with a flow estimate for that service area, about 42,500 gallons per day. And that included a 10% expansion for future growth within the district. So back to Alpine Fields. After we had that meeting back in September of last year, the town and ourselves went out to Alpine Field and did some test fits in November. Unfortunately, we didn't find exactly what we were looking for. We ended up finding signs of high seasonal groundwater, which becomes a challenge with installing a septic system there. Not that it couldn't be done, but what you'd have to do is essentially create a large mound system where you bring in some fill, which gets pretty expensive. But even more importantly, in this case, it would also limit Windham Regional or Windham Foundation's use of that site, because they currently use that for spreading the way from the cheese factory. So we had to go back to the drawing board a bit here for finding another site. So what have we done since those test fits back in November? To be honest, it's been quite a challenge to find a good site here within a reasonable distance of the village. But we've been working with the town to really try to take a thorough pass of all areas that could be considered. One of the first things we did, it's called a cluster analysis. Essentially, instead of trying to find one large site that would work for the whole village, we try to see if there's maybe 3 or 4 smaller areas that we could use. Unfortunately, that really didn't turn out too many good locations because of all the setback requirements from wells and the flood zone and things like that. We also considered forested sites for what's called a spray field system. What we ran into there was that there's a lot of recreation in some of the forested areas around the village, so we didn't really find a great forested site. So then we said, okay, we really got to increase our radius that we're looking outside of the town. And so we worked with the town, ended up identifying 14 sites, reached out to property owners. We talked to people familiar with those properties and kind of narrowed those 14 down to 2. One being the Spring Hill Farm site up on Heatonville Road. The Upper Howland Mill site, Windham Foundation property, to the east of the village on 120. And again, Village Park we're still thinking about the Village Park. However, can't use that site unless we have a drinking water system. So this is just a map showing some of the areas that we considered. Ultimately narrowed those down to those 3 shown in red. So just kind of a summary of what we found each of those sites. Village Park site, decent soils below what we call a confining layer. However, like I said, there's a lot of challenges with that site. The Upper Howland Mill site ran into high groundwater again, this time only 12 to 14 inches below grade, so not ideal. And based on those soils, again, it had to be a really large mound system, and ultimately there's just not enough area with acceptable slopes on that site, so that ended up being too small. The Spring Hill Farm site, however, we did run into some signs of seasonal high groundwater, but much better, a little deeper, which is a good thing. And that site's pretty large and would be feasible. So now we have a feasible site. We started looking at what type of wastewater systems could we go for. We focused here on decentralized soil-based systems, so we're not talking about a conventional wastewater treatment plant with open tanks that are kind of notorious for being odorous. We're talking about a subsurface system that's mostly below grade. So 3 components of a wastewater system: collection system, getting all the wastewater from the houses to a treatment system. And there's the treatment system. You also see us refer to it as a water resource recovery system. And then there's the return system. So after it's treated, back into the ground. So I'm just going to kind of briefly talk about all the different technologies we looked at for each of those 3 components. So starting with the collection system, there's generally 2 types: conventional and septic tank effluent. Conventionals, a lot of times used for some of those larger communities. Think about sewer system and manholes in a city, where the solids and the wastewater is transported right from the house, right out of pipe, and right into the collection system, which is a pretty big diameter piping. And then there's septic tank effluent collection systems, a little different. This is a lot of time used for smaller communities like Grafton, and the concept here is you still would have a septic tank at each house, and there'd be what's called an effluent filter on that septic tank. So the solids all stay in the septic tank, and then just the liquid wastewater goes out to the treatment system. There's a couple benefits there. Number one, because you're not transferring solids, you could use smaller diameter piping, and then you can install that piping with what's called horizontal directional drilling. So you don't have to do as much open excavation to install it. Then we looked at 3 treatment systems. We were only considering technologies that are approved in the indirect discharge program. So the ones we looked at are recirculating sand filters, a media filter, and then a fixed bed bioreactor. So the first one, sand filter, really simple. The wastewater is distributed over a bed of sand, percolates through. That sand essentially treats the wastewater, comes out cleaner. A portion of that is recirculated, and then it goes to the return system. And I just mentioned too, those they would be completely buried under a field. The next one we looked at is a media filter. These are a little different, but very similar. They're all very similar treatment concepts. These, however, come in kind of prefabricated fiberglass tanks. Essentially, inside those tanks is a whole bunch of textile media. So the wastewater gets sprayed over the media, percolates through. There's some microorganisms on that media, which treats the wastewater. Usually these, this picture down on the right is of a completed system. A lot of times those are installed a couple feet out of the ground just to provide access when there's snow. And then the final one, again, very similar, a little bit different style media. These ones are installed in a precast concrete tank. Some air is flowing. And then finally, last component here, the return systems. We looked at 3 types: a conventional absorption field, gravelless geotextile sand filter, and drift dispersal systems. Like I mentioned, we also looked at spray fields, but we couldn't find a good site for those, so I'm not going to talk about it here. So, conventional absorption field, that's what probably most of you have in your backyard. Essentially, a perforated pipe and a gravel trench, except this would be much larger for the whole. Gravelless geotextile sand filters. These are considered an innovative and alternative wastewater technology in Vermont. These systems have a lot of unique advantages for specific sites. Essentially what it is, a little bit more complicated. It's another bigger diameter perforated pipe wrapped in some sort of aggregate, wrapped in a geotextile media, and then put in a bed of sand. It does have some advantages at certain sites because you can essentially have less trench length. And then the final one, drift dispersal system, also an innovative and alternative wastewater technology. These are getting more popular. It's pretty simple. There's a pump tank, pumps the liquid wastewater out into multiple fields of really small diameter piping, and those pipes have little holes, little emitters in it that just send a small amount of wastewater into the ground. These ones have a lot of advantages, pretty inexpensive to install, and you can also install them pretty shallow. So it's really beneficial for sites like some of these sites here where there's high groundwater. So we took all those different components of the wastewater system, tried to come up with a few alternatives to dive into in more detail and compare the costs. So the first one is a wastewater system at the Spring Hill farm site. The second one would be a wastewater system at the Village Park site. But like I said, that would require drinking water system, so we're not going to talk about that one tonight. Number 3 is just a drinking water system, but again, those require that drinking water PER. And then the fourth one, always an option, is do nothing, which is pretty self-explanatory. So just to kind of provide a little bit more detail on alternative number 1, the wastewater system at the Spring Hill farm site, try to give you guys a little bit of sense of what that would look like. So what we propose for this alternative is called septic tank effluent pump system. So there'd be septic tanks at each parcel still with a pump in it and a filter that would send the wastewater up to the Spring Hill farm site. Couldn't do gravity for that location because the Spring Hill farm site is uphill compared to the village. And then at that site would be the treatment system, in this case, a recirculating sand filter, and then a drip dispersal system underneath the field. So this might be kind of tough for some people to see, but those purple lines are a rough outline of the collection system piping. And it would go all the way up to the Spring Hill farm site. Kind of unique situation here that the Spring Hill farm site is so high that we'd actually have to add another pump station to get it up the rest of the hill. And then this is just a sketch to show the components that would be installed at the Spring Hill farm site. So the wastewater would go up the hill to a couple of tanks that are below grade, and then into the sand filters, also below grade for treatment, out to another tank where it then pumps into the drip dispersal system. So the small diameter pipes installed pretty shallow, relatively shallow underneath the soil system, underneath the ground. And there would be one small building for some of the electrical component. So the question that everybody usually likes to know is what's the cost for the system? So looking at the capital cost, we do what's called like a class 4 cost estimate. So we came up with a cost estimate for the collection system, the treatment system, the dispersal system, and all of that together for this alternative at the Spring Hill farm site. In today's dollars, around $8 million. And we also come up with an estimate for the annual operation and maintenance costs. So that number would include the labor, part-time labor to maintain and operate the system. It would include pumping out all the septic systems septic tanks, in the collection system at each parcel. So that would happen on a reoccurring schedule. And then things like equipment replacements, electrical, contingency, administrative costs, all that's wrapped into that approximately $116,000 a year. So then we say, we're trying to get at what would the user cost be, right? So what this table does, a lot in this table, but essentially takes that $8 million and escalates that, because we're assuming it's not gonna be constructed this year. There's gonna be some price increases. By the time it actually gets constructed, it might be 3 years down the road. So we escalate that number, and then what this table does is it subtracts that $4 million in ARPA funding that we talked about earlier. That's already been awarded to the village. And you can see here, the bottom number on the bottom, about $5 million of that cost would need to be financed by the users in the village. So, when we're coming up with user fees, we try to compare them to what's called the EPA sewer affordability rate. So the EPA states that an affordable user rate for a single family household, which we call 1 ERU, which stands for equivalent residential unit, needs to be less than 2% of the median household income in order to be considered affordable under their criteria. So the median household income for Grafton, about $68,000. So 2% of that is about $1,363. So to be considered affordable for Grafton, according to the EPA, you need to be under that number. Just want to point out too, there's a couple ways that you can go about billing this, but we're assuming that only those parcels and property owners included in the sewer district would be responsible for repayment of that. So only the users would be paying that fee, not other users, not other folks in town of Grafton. So this table shows an estimate of what the user fees would be for funding that about $5 million, as I mentioned. So what we're doing here is we're assuming a loan through the Clean Water State Revolving Fund, which is a 30-year loan at 2%. So when you factor that in, along with the annual O&M costs, we come up with a total cost for single family household per year of $3,500, which is obviously much more expensive than the affordability rate. So the question becomes, how do we get to an affordable user fee? And cutting to the chase, essentially the entire project cost would need to be covered under a grant instead of a loan. That would have to be repaid at an interest rate. So if, for example, we say we got funding, grant funding for 100% of those project costs, in that case, the users would only be responsible for repaying the annual O&M costs, essentially. So that spread across the total number of ERUs in the proposed district is about $1,200 a year per ERU. So about $100 a month if that was that. And I should mention too, right? We have 84 parcels in the district, 97 ERUs. So some of the parcels have more than one ERU. For example, some of the businesses, restaurant, for example, would have 2 or 3 ERUs. And so we'll get into this a lot more probably during the 90% report, but I just wanted to mention too that there's a lot of options. If this project wherever it goes forward, there's a lot of options for billing. That can be on an ERU basis, it can be on a tax assessment basis, or it can be on a flow basis. A lot of times what happens is, say you do have a certain amount of the capital cost you're trying to repay, that would be done based on the ERU basis. And then the annual O&M cost, that would a lot of times be done on a flow basis. So parcels that use more water, send more water to the wastewater system would pay a larger percent of the annual cost. So finally, next step, I know I've been talking for a while here. Tonight, we just want to, right after the slide, we'll open it up to some questions, get any comments, questions addressed. We're trying to get a sense of what the community's thinking after giving this presentation. And then we'll be able to finalize certain technical comments that we've got back from regulatory agencies for the 60% related to wastewater. But then the next step is going to have to be town deciding decision to proceed with the drinking water PDR. So, oh, that was a lot. I think that was all I had, right? Yeah. Okay. Thank you, everybody. Yeah, we're gonna. Yeah.
Do you want to see if the folk from DEC have anything they want to say before open
Yeah. Sure.
questions? And we're gonna see how the speaker works.
All the D's, Emily, all the D's, Lynette, anyone on DEC, if you guys want to say anything before we open it up to questions, feel free to do so.
Do we just want to start by introducing who's here from DEC? Does that make sense for you? Did I freeze?
No, I can hear you, Lynette.
Okay. So I'm Lynette Cladone with the Water Investment Division. So let's do Water Investment Division and then drinking water staff and drinking water groundwater protection, then wastewater staff and drinking water groundwater protection division, and then waste management division. So Emily, you're next.
I'm Emily Hackett. I work in the Clean Water SRF program with Lynette. Can you guys hear us okay?
Hey, everybody. Morgan's computer shut down, so bear with us 1 second. We'll be back momentarily.
Okay.
Oh, okay, thank you.
That's frustrating. Did you hear the intro to the introductions?
The problem is,
Chris?
public meeting, you've got people on, you don't have the first one.
This didn't happen last time. Yeah. Gosh, and I don't know how long it's gonna take.
So the issue we're having right now is, because the basically a public meeting with both in-person and remote participants, we have to give access to all
Okay.
participants, right? You have to treat them, everybody the same. So her computer's reloading back up and things happen. It'll be all right.
No problem.
I can log in so that it remains the host. If that, no, it's just USB.
Yeah. And the owl is actually putting out pretty good sound. Let's see if I can not connected.
We have
Yeah.
recording.
I just have to move this one.
Okay, go again.
Can you guys hear us on Zoom?
Yes, we can.
Sure can.
Okay, we
Should-
gotcha.
Did you hear the initial introductions or did you miss out on that?
No, we missed out on everything, unfortunately.
And,
Okay.
we're having speaker issues, Lynette, so just speak very loudly and enunciate clearly.
Okay. I had suggested that the DEC staff introduce themselves, starting with WID, then drinking water, then wastewater, then sites management. So I'm going to start. I'm Lynette Cladone. I'm with the Clean Water State Revolving Fund and the Village Initiative, and work in the Water Investment Division. I'm going to pass to Emily.
I'm Emily Hackett. I work in the Clean Water SRF. I'm the design engineer for the project and in charge of the ARPA Village Water and Wastewater grants.
And then I will go. My name is Megan Young. I'm the Sustainable Infrastructure and Management Program Manager for the Public Drinking Water Program. And my program regulates the technical, managerial, and financial capacity of all public drinking water systems. And I will pass it on to Nate Kai, who is in the Drinking Water and Groundwater Protection Division on the wastewater side.
Yeah, hello, I'm Nate Kai. I'm the supervisor for the indirect discharge and underground injection control programs. And I will pass it to Ashwak.
Hi, everybody. So I'm Ashwak. I'm environmental analyst working for the indirect discharge program, and I'm responsible for permitting the ARPA funded wastewater villages projects.
Casey.
And I'll go next. My name is Casey Caffin, and I'm with the Waste Management and Prevention Division Sites Management Program. And we're involved with the PFAS contamination that was detected at the school supply well. And I'll turn it finally to Christy.
Thanks, Casey. I'm Christy Herzer. I'm the temporary project manager for the PFAS contamination at the elementary school.
That's all of us.
Do you guys have anything any comments you want to make on the 60% report or the news that was delivered to the town late yesterday and this morning, or anything you want to say? Don't go at once.
I think Kyle and Aaron covered most of it pretty well.
Okay.
But we're here to answer questions if there are questions.
All right. So I'm Chris Campany, Executive Director of Inland Regional Commission. We're just serving a facilitating role, and I'm just going to help manage the Q&A process. Morgan, you're monitoring the computer, so what we're going to do is make sure that we cover questions from both people in the room and then people also online, folk online. If you don't, when we get to you guys, if you don't know how to raise your hand using Zoom, just feel free to speak up when the time comes. So let's start here in the room. Any questions? Back in the back, black shirt.
How long does this system go without power?
The question for everybody online is how long can the system go without power?
So we wouldn't reuse your existing septic tanks. We'd replace the septic tanks, especially unless it was like just installed. And so generally there is storage capacity in the tank itself. Then at the actual treatment site would be a generator. So right now, just putting on the wastewater blinders, wastewater with no drinking water, from a public capacity, you know, if your power goes out, typically your well goes out. If you are so lucky to have a generator, then the wastewater pump would also be on the generator. And then once it gets to the treatment site, there would definitely be a generator to support the treatment site.
We have a person in the button down blue shirt.
Actually, from the clarification that I understand. So we would have, so people would know about septic tanks, right? They would probably be something in the place, right? But some might be, right?
Well, yeah, so generally Why is this? Because right now,
So the question,
all right, really,
the question was
the
asked is,
first part of the question was, would people continue to have septic tanks? And so the quick answer is yes. Two reasons for that. One is, if you're new construction or, a lot of municipal systems, they were built in the 1800s and everyone's basement piping is meant to go out the front door and into a collection system through manholes in the street. But I think we can assume most of your houses go to a septic tank in the back. And so one is maintaining that system actually makes it technically easier to do. Two is, from a municipal wastewater standpoint, odors from solid processing is one of the largest nuisances. Right now, you have a solid processing system in place. It's a licensed DEC hauler with a properly sized septic tank. That's 3 to 7 years where your septic tank should be pumped. So we're not talking about weekly pumping, monthly pumping, yearly pumping. 3 for a very fully sized house that maybe is used a lot with maybe toddlers and other things running around, to maybe 2 adults living alone, maybe it's 7 years. And that's the great part, is that you would not pump the septic tanks willy-nilly. If what happens at my house is they come and they stick the sludge judge down and see how much sludge is in the tank, you're good for another 2 years. And then you pump as needed. So the pumping would not happen all at the same time. It'd be staggered based on the size. And part of that O&M fee. That's really.
And Aaron, just another quick question. And typically, if everybody would have their own septic, but everything's being managed as a system, right?
Yes, and part of that operation and maintenance fee. So what does that mean? It definitely means easement stuff, because the town must be able to get to your septic tank to pump it. So if this project proceeded past what we're doing here, which is the preliminary engineering feasibility analysis, and went to design, something everyone in the area would need to know, you have to give the town permission to get to your septic tank.
That's all right. But I don't understand it, but at the end of the day, when we're talking about now, it's still not about. Is that correct?
Well, the license, so the question is, we're talking about dealing with wastewater, not solids. This is comprehensive. So the town would be paying, typically how it happens is maybe there's a 3-year contract, they go out to bid with currently licensed septic haulers. And then they're on call and will, part of the operation and maintenance will be to identify what tanks we're looking at this year, go and pump. And typically, because there'll be a few that needed to be pumped, they can coordinate with the homeowner and stick. So that's the way your solids will be managed through licensed haulers.
Hands-on way in the town itself.
Absolutely.
Right. So the water is really what we do.
The gray, let's just be clear, since we're talking about a water, the gray water, yes, yes. So we're talking about the water that then is conveyed to the treatment site, which I'm calling the gray water for the sake of the word water.
And then the solid, and I don't know enough about it.
Well, they're not, they're gonna be pumped and hauled. Exactly, like they've always have been. Yes, sir.
Really no difference that perhaps some people get new about it. And the same thing that can happen on one, going forward, separate.
And except for the folks who are struggling with their tank now, there's definitely people who are pumping far more than that 3 to 7 years. Totally. Yep. Yeah.
Okay, so now, I'm just, then I got, then I get a question.
Oh, geez.
Right now, I'm it does, again, does really that. So the other part of contamination, I mean, my understanding was that in certain conditions, the possibility of flood water to other kinds of water situation would come and bring contaminants back. In fact, the mineral is one. The only contaminant that right now we were worried about it, right? So that's only something that has been dealt with in the rainwater, or not.
Absolutely. If you are,
So
yeah, go ahead, Chris. Do you want?
So
No,
the question was basically, So the issue here is you're still gonna have on-site septic tanks, and then the gray water will be treated off-site. And so the question was, what are we treating that's of concern? It seemed like in the presentation, the emphasis was on PFAS. Are we also concerned about other contaminants? And what does this imply also for system-wide, community-wide flood resilience I guess it could be both comparing the on-site systems and the risk posed by them during a flood situation, and then a community system, how would it respond during a flood situation? Sure.
So, let's go existing conditions. So the existing conditions, if you are in the flood zone and it floods, your existing on-site wastewater system is going to be significantly impacted and could absolutely be a source. Yeah, we've focused on the really complicated contamination. So really simple contamination, fecal coliform, right? It's like poop. Yeah, that's what happens with a sanitary wastewater system. And if they fail, and they absolutely fail, often they fail to the surface, and then you see the failure at the surface, and you can figure out based on the olfactory test pretty quickly what's going on. But sometimes they don't fail to the surface, depending on the soils where it's installed. And so it can travel towards your well, towards a water body for environmental contamination. So those are definitely, when it comes to flooding or just frankly failing systems, they only have a certain shelf life. The way even our high-tech systems are all doing the same thing. Biological materials grow up on the soils, and that biology is what treats the wastewater and makes it suitable to return back to the groundwater. But over time, that can clog. Just too much biology grows and the system can fail. When it's in a treatment system that we're talking about, that's managed. So we don't have that concern. So when we talk about the new system, there's parcels that are like 100% in the floodplain. There's no place you could put the septic tank that wouldn't be. In that case, the septic tank now is our only concern from a potential route. We've used locked covers in that case. So watertight locked covers, they actually work really well. And that's the way you stop flood from getting in. Now, if the whole house is flooded to the point where it's going in the toilet, you know, we've got a whole different problem on our hands. That it is what it is. From the site that's been chosen, and one of the substantial reasons when you look at our, and this was discussed a lot further during the 30% design, is that we don't put one of these sites in a 100-year flood zone, right? So the particular site we're talking about, but also you'll notice a trend, Alpine Field and Upper Helen Mills, we're getting way up of the flood zone. So even if there was, you know, I go right through Londonderry, you know, even if something really tragic happened, the wastewater system from the point it's all coming together would be, you know, way out of the flood. Is that complete?
Yes, I won't monopolize, I want to get back to that.
Okay.
So let's go to the fellow in the light magenta, I guess we'll call that.
I'm late to the party, so maybe address it earlier. What is the longevity of these systems? Is it 5 years, 10 years, 20 years?
The question is, what's the longevity of a community soil-based wastewater treatment system?
So we've got all different parts, right? So a concrete septic tank, if designed, that can last for a good, I mean, I'll say 50 years, and then I'm sure half the audience will argue with me and say my tank's been there for longer. But precast concrete tank, good. Metal riser covers, good for a good long time. The type of piping we're talking about putting in the ground, this is not ancient pipe. This is small diameter, likely high density polyethylene. And so that's got an extremely long life. Where you're looking at a 20 to 30-year life is your mechanical components. And so when we talked about this O&M, so that'd be a pump in your tank, not those, I'm just going to use that example. I don't think it's the example the costs are based on, but one of those systems had fiberglass tanks. Those last for a very long time, but the components in it you would need to change. And so when we look at that O&M number, that's built in to refreshing and putting away money to replace these components as we might need them to be replaced, so.
Yeah, another quick question. Do you have any of these systems working for 50 years, 25 years, 10 years? Right now, is there any in Vermont working?
I'll let DEC comment specifically on Vermont, but absolutely, yes, this is not, none of this, I'd say the drip dispersal is the newest, and those systems are easy 20 years in the ground.
The question was,
Sorry,
what, do we have any aid systems that have been operating for decades?
Chris, you gotta manage me better. I'm clearly unmanageable, sorry.
And so, Erin just gave her answer, but, particularly, I guess, Lynette and Emily, do you guys have
Yes.
any options?
Yes, the Rochester system was built in the 1970s in the federal grant days.
The Rochester system was built in the 1970s.
Yes.
All right, Eric, you had a question.
How well does the sand remove PFAS and pharmaceuticals?
The question from Eric is how well do sand filters remove PFAS and pharmaceuticals, and I guess other kind of more resilient, clingy, I'm forgetting the proper term, but more kind of long-lived chemicals.
If it doesn't, what further filtration is needed?
And if it doesn't, what further filtration is needed? Do you want to go, Aaron, or do you need to answer that?
Either one could take it.
Yeah, so currently PFAS is not regulated in wastewater discharge in Vermont, and there are not expectations for pharmaceutical treatment. The types of pollutants that we're looking to remove are viruses, bacteria, and we also get some phosphorus benefit. Some indirect discharge systems require nitrogen, and Nate and Ashwak can jump in to talk about that more.
So just to make sure everybody heard, primarily these soil-based systems are designed biological materials, and then to some extent nutrients, and there may be other additional things you need to add to the system to deal with things like nitrogen and phosphorus. Go ahead.
I'm just gonna quickly contribute and so that's where we get into the complexity of this project. Because the scope was build a system to meet current regulatory standards. And now there's a question of what are we treating to? Does knowing that we would pick up wastewater from wells that currently are contaminating the Southend, even though, just as Lynette described, that's not a current regulatory standard that another town would be held to, we don't want to be moving contamination around from where we know it is to another uncontaminated part of Grafton. And also why we much prefer to take it out in the water treatment and then have it not an issue when we talk about then our traditional wastewater components will be treated for it.
Yes, sir, it's man in the green.
Yeah, mine's a little different. We have a 30, 69 years for 72 products. We have a project plans on the contract, and that's what the consumer demand is. Not pretty much, not saying anybody else, but we didn't like it. So we're going to go to another water supply center. We're going to find out the next place that
I'm going to manage Aaron. The question was, we have the 30-60 and we're going to have a 90% study with graded wastewater. Of course, before we get to the 90% study, there's going to have to be a water study that catches up if the town wants to do that. And so the question is, when are we going to start seeing budgets? I think you saw a preliminary cost estimation or opinion is what you called it, but Aaron, go ahead.
I think the question is,
Oh, okay.
are we on budget? And then I would ask that Lynette or Emily talk about the funding for the additional requests. So right now, we are working within the budget we were given to do the initial site analysis there was additional budget allocated through a different funding source. And all the budget is, through grant and, non-collectible loan sources. I don't know, there's apparently a wiggle word we have to use to not call it a grant, but there is no dollars spent on, from the town budget at all, other than the very, very generous use of the labor and excavating equipment to install the message.
Hold on one second. So Lynette, anything you want to follow up on, or Emily, or anybody else online
Well, for the next phase.
for the next phase?
Yep, so the ARPA grant can cover a lot of additional things for the project, as well as the drinking water PER that's been written into the grant, which will be coming to this town here probably very shortly. As we finished it last week, I believe it's being internally reviewed right now. So all of those things, final design, some additional work that might be needed, whether it's a bond vote, any additional like project coordinator services, those are all can be covered under the ARPA grant. There's also what Aaron was talking about is the forgivable loan we call subsidy, which the community is just about was approved for. I can't remember what the amount was. It was a small amount to come in for that forgivable loan to pay for that additional lands that were looked at by Ty and Bond with the test pits. So as of right now, everything for the project is either being covered by the Engineering Planning Advance Grant, the ARPA grant, and subsidy through the Clean Water SRF program.
And that reminded me, as Kyle was saying this, I thought of this. I want to point out, in addition to the town staff and Morgan and town board members and Kyle and I, a very sizable quantity of folks from DEC came out to every single one of these test pits with us. So when we say this has been a collaborative effort with DEC, they absolutely are full and present at this project, understanding what's happening and trying to provide us as the engineers their best feedback on their thoughts as well. So we're not having a back and forth. We're coming and looking at the dirt together and saying, okay, we're all seeing the same thing. Let's move on. But they've also been extremely present stakeholders in this process.
All right, I'm going to take this question and then we're going to go to give people online a chance to ask a question.
I'm literally, I really like the question. That I thought that in the scope of work of your proposal, that the drinking water was something like that. Are you suggesting now that drinking water is a full scope and a new check class? That doesn't sound like what I mean.
The question.
Oh, I'd be happy to explain that. And that's sort of what I was trying to.
Aaron, recap the question.
Oh, let me repeat the question. So the question was, originally, we have a water system in our scope. How is that different than a water system PER? So the question is, so it's a wastewater project is what we were doing. And as part of the wastewater project, the question is, what's the best way to resolve as is seen the problem with wastewater on the parcels? So in other words, if it's felt that there's not a limiting condition on wastewater, but really you just want to protect your on-site drinking wells, then maybe a drinking water system is the solution. So that was one alternative focused on septic contamination. At the time in the scope, because we knew it was a concern, the idea that this very quickly could be regulated number wasn't even on anyone's radar and has developed along the course of this project. And so, as of this morning, we are told that has changed.
But nonetheless, though, it's still going to be really high according to what I have.
Oh, yeah, you got to do, so the question is additional budget, still budget that is provided for by the ARPA grant, that there's no town contribution. Oh, absolutely, yes.
All right.
The question was, oh, and so I think, is that the nature of your question? The $4 million ARPA grant is not enough. That's 100% what Kyle said. The question is now, what's the project? What is the ideal project based on the town's opinion from Grafton? And then finding the additional funding for it, which there's tremendous consideration from the state to get that additional funding. You don't even know what number you're looking for yet without going through this process.
All right, we're still gonna take questions from in the room, but I want to give folks online a chance. So do we have any hands up or any questions?
Yeah, hi, this is Charles Bowman. I'm online. My wife and I own the house that is right down the driveway from where you're all parking, which is next to the school. And since 2018, I was notified by the state that there's PFAS that was taken care of at the school and that they wanted to monitor our well. So since that period of time, we've had monitoring and we've had periods where there's low PFAS and periods where PFAS, we have failed both the federal standard and the state standard. The federal standard has been reduced, and I assume that Vermont will be accepting the federal standard. I really have two questions, and I see there's someone named, I'm sorry, I didn't get her last name, but Casey from the DEC. One is, at some point, I would like the state to do what they promised, which was to put in a system in our home to purify the water and reduce the amount of PFAS in our water. And the second question is, and I see there are select board members in the audience and online. If there is to be a vote, I'd like a clear answer that someone like my wife and I that are not residents of the state of Vermont have the right to vote for these projects, pro or con. And so if I could get that opinion also, I'd appreciate it. And
Let's start with DEC first, and then we'll go to the select board.
Sure thing. This is Casey Caffin with the Waste Management and Prevention Division. Mr. Bonin, I do know that your well has been sampling and it has occasionally hovered around the Vermont drinking water standard right now. And I'd be happy to talk with you about your individual circumstance and our approach to installing wells. But for the area, or for installing well treatment or point of entry treatment systems, for the area in general, we're monitoring a number of different locations and for PFAS contamination in private residential wells. And that the intersection between that and this wastewater water supply in this conversation is something that we're definitely interested in trying to ensure that everyone has safe drinking water for the long term.
Joe or Seth, you want to answer the question about voting?
It's Charlie, we can't answer that question. That has to be decided by the town. The only thing I can tell you is that the question came up during the wind, and the town said that out-of-staters or non-residents cannot vote. But I don't know what's going to happen with this. That's something that would have to be decided by the town.
And that might require a legal opinion too, I would think.
Legal opinion.
Well,
Other
Joe, I appreciate that answer, but that's the answer that I've heard before, which has to do with voting for positions in the town. This is entirely different. This is a statewide issue, and it's a bond issue. There's many issues involved here, and somebody must know the answer as to whether a resident that's affected, especially us, who has PFAS in their water, can vote or not. That's all I want to know. I just don't want to go through this later when there is a vote and nobody knows the answer. And I'm not asking for an answer. I'm asking for someone to consider. And I think it's at a state level as to whether a non-resident can vote on something like this versus voting for an elected position. And Casey, I appreciate that information, and I don't know if you want to give your phone number to me, but if you want me to talk to you, I'd be happy to have the phone number, or you could get it to Morgan and I'll get it from Morgan.
Morgan's nodding her, happy to intercede here and connect you two.
Yes, that would be excellent. I can also be reached email, which is just my name, casey.cathan@vermont.gov.
Are there other questions online? Any hands up or? All right, we'll go back to the room. The woman in the back corner.
Hello, Chris. Hello, Chris. I'm sorry, I couldn't get my hand raised. This is Suzanne Welch. May I ask a question?
Sure.
Okay, thank you. So first, I want to thank Aaron and Lynette and the team for giving us tonight a reality check on the cost of what this project is going to be. I remember when we received the $4 million grant from ARPA, we were hopeful that a wastewater system for Grafton would be paid for by that grant. And now what we're seeing is a cost 2 times that amount. And it's very interesting to step back and think about what's happening in Grafton, because coincidentally, we have a bridge, the Walker Bridge, which is also going to cost about $8 million. And in some way, shape, or form, if we go down this path, we'd have to figure out a way to fund both. So with the magnitude of this situation, I think it would be very helpful to have a comprehensive survey of the community to get feedback about this proposal as part of the follow-up to the 60% report. Because really, I think the people involved in this meeting are going to get our questions answered very well. But the fact is, I think there's more of a community involvement that's required confronting a 2x possible budget for this project.
Anybody want to respond? Okay. Any other questions online? All right, the person in the back corner.
My question is relates to the next meeting's about involvement. And then keep that. So I'm pretty maybe that the last time that we were in June, that the laws of the feedback would be the cleaning harmful and million. So I'm wondering if they have to switch, and I'm wondering whether as you go forward, is looking at the clause completely law as equal, because it's impossible to determine if it's historical stuff that's in now, or is it stuff that you added to water now? Is it completely are we unable to even look at that?
So the question, is, so at the last meeting, it was discussed, and previously, I guess it was discussed that the probable source of the PFAS was chemicals used in the school that found its way into the wastewater. And are we, in talking and considering PFAS, I guess other chemicals, are we talking about legacy water pollution, and is the school using something different now? Or are we talking about addressing, you know, or is this going to be an ongoing contaminant issue? Is that a fair characterization?
Yeah, and isn't an agency cost, or is that so impossible to just give up and start?
Okay.
Down and out the road.
So and then is someone able to look at the cost, or do we give up and look at something else going down the road? Aaron?
Oh, no.
Okay, somebody from
So we actually no way are involved with the forensic or even remote with the contamination issue. So that's a DEC question.
So water people at DEC or wastewater people, what's your opinion on that?
I would start with Casey and Christy on, you know, what the existing investigation looks at.
I'll start and take a stab at it. And I'll put a disclaimer out here that our regular project manager had a baby last night, so I'm pitch hitting a little bit. And while I'm familiar with PFAS investigations, generally my details of the Grafton scenario are limited to what I was able to go through before this meeting. I think in a general sense, PFAS from wastewater systems that then impact public supplies are believed to be from those residential or commercial industrial products like the cleaning solutions that are in the school. And it is both an issue of kind of that residual contamination that's in the groundwater, going into those supply wells and recirculating into those wastewater systems. But there are also new products that have PFAS compounds within them that can impact our wastewater systems. For the specifics of the Grafton School, it is my understanding that the detections that were originally found in the school supply well and have subsequently been detected in some of the residential wells in the area are believed to be due to that larger wastewater system associated with the school itself, and the products that particularly floor cleaning products that schools would have historically used.
Anybody else from DEC?
Megan?
From an indirect discharge, for the indirect discharge program. So right now for the current rules, so the presence of PFAS in the effluent is not addressed in the current rules. So, yeah.
And this is Megan Young, and I will just defer to exactly what Casey said. That's as much information as I have as well for Grafton School.
I think generally just to address why we were looking at the Grafton water supply, we were looking at a select number of public schools supply wells. And that was when we detected the PFAS and then made the connection to the wastewater system. It did not begin as an investigation of the wastewater system that then expanded into the supply wells. And
other questions in the room? The woman in the back?
So would it be possible that the school and the neighborhood around it would be pronounced with they would be actual
So the question is it possible that the school in the surrounding area is a brownfield situation and it's not the wastewater system that's actually a problem?
I'll take that. So, brownfields are properties that are potentially contaminated. So it's a very broad definition. We do have, our neighboring state in New Hampshire sort of set us down this path of looking at the school drinking water with regards to potential contamination from leach fields. So, the current working hypothesis or conceptual site model in our world is, septic leach fields are the current potential source.
So I'm going to ask a clarifying question that maybe Aaron can get to. So as part of the 30% study, it's up to 60% study, were wells in the village or elsewhere within the wastewater shed, were they tested for other biologicals, nutrients, other contaminants, or has the focus just been solely on PFAS?
Again, Ty and Bond has done no PFAS work. So that's just part of our knowledge of the DEC results. The wells and well survey, there was information compiled earlier in an earlier study phase that we've been able to use. But no, we're not having our scope any well testing.
Okay.
But I've got a question. I can't believe
hold on
that's
a second. So the response certification. So Ty and Bond, as part of their 30% study, was able to rely on a prior well sampling study, but that was not done as part of this 30% or 60% study. So this particular study didn't research what else may or may not be in village drinking water systems.
But what was here that the thought that it could be a brownfield site, is it mills or textile mill or? A tennis, like a ceiling of a tennis, like a painting and ceiling asphalt.
So the
So
comment,
the question
the comment in
is,
the room was that there's a
I just had to know, like, what?
the comment in the room was that there was a site in town that did tennis court sealing and used other chemicals. Is that, and I'm just asking this clarifying, was that even the one in Cambridgeport?
No, it's still going in there.
But was that the location? Got it, okay, got it. So where is it, just for everybody knows, where did you
That
say?
way?
I saw the general direction, but where's the location and it? Between the bridge and the bridge over the section? Oh, here in the village. Got it. Got it.
Well, just again, we're calling them forever chemicals because they persist in the environment for a very long time. Oh, yeah, it's like gene transformers. You didn't know what you didn't know.
So now the conversation is about other persistent chemicals like GE transformers,
Sorry.
Love Canal and other places. So we're really getting pretty far afield here. Aaron, you had a question or comment?
No, that was it. That I
Okay.
had, the question in general was what had happened historically that the Brownfield question was asked, and now that's been answered in regard to the tennis court company.
We have other questions in the room, and then we're gonna go back to online. The person in the back corner? How many, the question is, how many wells in the village have tested positive for PFAS? I guess that's a question for DEC.
It certainly is, and I believe we're at around a dozen wells, residential wells tested, and there are a number of monitoring wells that were installed to try and address that issue that was just being spoken to of whether there might be other sources. You know, the approach for investigating sites is to look to a likely source, but also to install enough monitoring wells that you can see if there's other potential sites impacting or sources impacting your site. So we're at about a dozen residential wells that have been tested for PFAS, and about half of those have had some detection of PFAS. Again, we're in this period where the Vermont standard is 20 parts per trillion, and we've had 2 residential wells that have kind of fluctuated around that 20 parts per trillion standard. And the direction of federal standards is lowering, and that will certainly result in more residential wells being above that potential new standard.
And Casey, I'm gonna ask a clarifying question just because others may have it. As part of your testing, are you testing only for PFAS or are you testing for a broader spectrum of these chemicals?
We are testing for a broad suite of PFAS compounds. So there's numerous PFAS compounds. When we say PFAS, we're talking about a very broad world, and we're testing for usually around 36 different compounds, but it is limited to PFAS.
And okay, so not testing for nutrients, biologicals, or other things.
We are not regularly testing for those, and this is where my knowledge of the historic testing. I don't believe that's ever been done here in Grafton. It has only been PFAS. But I can be proven wrong.
Okay, great. Any other questions?
I'd add,
Oh, go
Chris,
ahead.
that the wastewater committee undertook a number of drinking water tests in the village, and that's where the previous data comes from. They did
When are you talking about that?
immediately before hiring Ty and Bond. So like Suzanne
Okay.
could probably talk more about that effort.
Okay, so it's fairly recent. Okay. A question in the yellow.
So it's been an hour and a half, and now my memory is fading about what I was saying in the beginning about that. And I know we're not talking about drinking water in detail, but the DEC now requires a water system, if a wastewater system is established, or does DEC require a water system? What
The question was, does DEC require a drinking water system? If a wastewater system is established, or do they require a drinking water system anyway? And at least, I guess the question is actually, under what conditions does DEC actually require a community drinking water system?
That's my question.
I'll answer that first, and DC maybe wants to add something else, but If the Village Park site were to be used for wastewater, I would definitely need one. If the Spring Hill Farm site was used for wastewater, doesn't necessarily need one, however, we recognize that we would potentially be transferring some of that PFAS up to that site, which is not the best practice. It's currently not regulated in the discharge.
And the people understand that transport mechanism, right? So if you've got a contaminated drinking water well, that you're then putting that waste, that water and whatever else is in it back into your septic system, and it's finding its way up to your brand new community wastewater treatment system, and you're kind of defeating the part of the purpose, so.
But just to clarify, the only, and I think requirement is a little strong, but strongly recommended that this project, this, as far as this evaluation, that's what we're doing, is looking at wastewater feasibility. The wastewater clause, while a drinking water report that's focused in the same level of detail purely on drinking water, that would go into the affordability, the technical feasibility, managerial aspects, and investigate multiple drinking water sources, get caught up to the same 60, be produced, and also be as advanced to the 60% stage, and then the analysis proceed together.
So we're gonna take one more question in the room, then we're gonna see who else is online, and then if folks want to, I'm gonna start wrapping this up because you've been incredibly patient and incredibly hot conditions. But let's take a question in the back corner, and then we're gonna go online and we'll see about wrapping it up. About property, or you're talking about where the system would be installed? Okay. So the question is, at what point does the property owner where the proposed district wastewater distribution system, are they brought into the process before you proceed with the 90% study? And have they already been brought into the process, Aaron, or what's the?
Yeah, so at this point, it's, can we consider this parcel feasible? Which is similar to our discussion with the Wyndham Foundation. Can we consider doing an investigation and what this would look like? So a whole bunch of parcels said no, which if you look at that sheet with all the 15 different places, some of those were eliminated because of flooding, but a lot of them were eliminated because we're not comfortable with even doing any testing or considering the feasibility. So at this point with the parcels, one of them is publicly owned. However, we know from the 30%, there's more than like $1 million of stormwater improvements to make Village Park feasible that has nothing to do with this drinking water issue, right? So that's got challenges. And then the question is with the second parcel, Suzanne's comment, it's far away. And then it is a working farm. So can we continue to cite this meeting that owner's requirements? And so far the answer is yes. So this is absolutely, there's no parcel we haven't spoken to the owner about, and they understand the nature.
And Aaron, I'm assuming that if they allowed a backhoe to come onto their property and dig a hole, they were involved in that. They gave permission to do that.
Oh, of course.
Right.
Yeah.
Okay.
Is there any information as to the land and the purpose of use the land after all after this?
No, that's 100% part of that discussion with that.
The response and was back and forth was, so discussion be had with the landowner about how the property could be reused, what would be the conditions of having the system on their site. And Aaron said, yes, of course, that would be part of the discussion. So
that's on that, we wouldn't even present it if it was a no. Most of those questions and at least feasibly answered. And as you get more fleshed out, but let me give you for instance, like a farm field mode. You wouldn't want brush hogging because if we grow like saplings, then we're not treating our wastewater. But paved a few times a year, can we put trees on it? No. So, we need to make sure that the road has access. And that's the responsibility of O&M to get to that site, but that site's gotta be plowed and opened, and that's the responsibility of the wastewater system, not the parcel owner. So there's like a ton of finicky questions, but that are really per the site and with the parcel owner as far as, can this be addressed, or is it not addressed? Is it not? Wherever we can, for that, and that would be able to build on, even not the end, is the project. Never again. Well, definitely that's the discussion, but not the nature. When we talk about typical, we'll use that word, but typical contamination, meaning, I think I did this last time too. You flush down a toilet, what you should flush down the toilet, which is, comes out of you and toilet paper, not kitty litter or diapers or baby wipes, which are a criminal
Or
thing.
paint.
Paint. You know. Right, so no, yeah, so in a typical standpoint and how this is being discussed, we're talking about the things that are naturally remediated by traveling through the soil. Now, this is where we are, that we are not a normal scenario. We are not treating typical wastewater. At this point, the discussion is, can we do that on any site? And the answer is, no, we've got to figure out what to do with this water, how to treat and how to address the water part of the situation. In addition to what is happening with the wells and the individual wells, and it's got to be comprehensive. We can't put those blinders on because of now the continuing understanding of what the levels of contamination are. So 100%. But normally, that's how it all works. It works great. The soil remediates these typical things. And by the time it joins the groundwater, we're completing the water cycle, but not anymore. This has become a different discussion now.
All right, do we have any questions online? You can raise your hand or just go ahead and speak up.
So, yeah, I just wanted to follow up on the question that I asked and wondered if Aaron would be willing to share what your plans are for gathering community feedback between now and the 90% study, especially because intervening will be the water study. I'm just wondering what your plans are for building that community feedback that you talked about earlier in your presentation.
Next steps is a good wrap up. Yeah.
Yeah, so what we're talking about at this point is Chris is here because we definitely need a point of public engagement. And so Windham Regional is serving as our clearinghouse and our public engagement standpoint. So Ty and Bond's going to be very focused on the technical aspects here, which I hope it's to be clear, there's a lot of complexity here that we're trying to sort and work out. And then it's communication and continued community communication. And I realized this team was working very, very hard and really spending a lot of time trying to figure out sites, and that was not well communicated. So we're making sure that between Ty and Bond and Windham Regional, a great plan is developed so we can be able to more regularly communicate through the town, and Morgan's part of that effort, making sure we get information out. So that will be developed, Suzanne, as we move on.
And I want to introduce Mike McConnell, stand up. He's one of our senior planners. He's going to be working with me on leading the outreach efforts. So we work with Ty and Bond. We'll be getting information out. We'll be working with Joe and Seth and the rest of the select board, and working with Morgan, developing the plan to solicit comments back from the public. If you go to the Windham Regional Commission homepage right now, which is windhamregional.org, and you look in the left-hand corner, you're going to see a link to a web page for what we're doing for Londonderry. So Grafton may want to do the same thing, through which information is compiled, made available to everybody, and through which comments can be solicited. But we'll be coming up with all that, and stay tuned for exactly what that process is going to look like. And I assume also the select board is gonna need to make a decision about the PER related to drinking water. And so the select board will be getting back to the public about what its decision is gonna be around that. And,
See, the select board's got to decide whether they're going to do the drinking water now.
say that, good morning.
I think he's related back to the vote, but the select board will just decide to move forward with this.
Yeah, it'd be at the select board decision whether or not to go for, to use part of their ARPA grant, the 3 point, the 3. Oh, it's separate, okay.
Yeah, separate.
But they'll be looking at using, it's fun, but it's funding you already have, right? It's a new grant. That's a new grant to do the drinking water PEO. So the select board will have discussion about that, and they'll be warning the meeting, and I'm sure they'll be soliciting public opinion on that. Eric, this will be the last question, we gotta wrap up.
Not so much a question, but a comment to try to clear up potential confusion. The planning commission is holding a meeting next Tuesday with invited guests that will be talking about biological treatment of wastewater. That's before it's put into the dispersal. And this should be viewed as complementary, not in competition or involved in what Time Bond is doing. We're taking a very broad look at technologies and how wastewater might be treated, regardless of what state might allow us.
So,
Just trying to.
are you chair of the planning commission?
No. That is.
So I assume the planning commission is inviting the public, the people of Grafton to participate in a meeting next Tuesday, at what time? Tuesday at 7 about biological pre-treatment of wastewater.
Yeah.
This is intended to be a complementary effort, not a conflicting or competing effort. And this gets into the concepts and biology and other things, so it's not necessarily about what Vermont allows or doesn't allow, but it's to introduce this idea in planning world and my landscape architecture background, it's be called a regenerative system, where you harness cycles in the environment and biology and other things, kind of an ecosystem approach to pre-treating wastewater. So if you're interested, go to wherever you go to get planning commission information, next Tuesday at 7 o'clock. All right, well, everybody, this is like the worst of possible conditions for a public meeting. Heat, noise, technical difficulties, and you've been very polite and patient with one another. I can't tell you how wonderful that is, because sometimes that doesn't always happen. So congratulate yourselves as a community for hanging in there and supporting one another. Thanks to Time Bond for their presentation. Thanks to all the state people for being here. Thanks to the select board members for participating. And remember, this is your project. Its fate is in your hands. Communicate with the select board. They've got a lot of decisions to make. It's on them. So, keep the lines of communication going and keep being decent to each other. And have a good night.